All right, good morning, everybody. It is just after 10 o'clock on the 26th of March, 2021. This morning, we're going to be adding mixed numbers. So it's just like yesterday's, except for instead of a mixed number and a fraction greater than one, or what we're calling an improper fraction, we're just going to be adding two mixed numbers. And what is the first one? It is 6, right? Because we were able to add this 1/3 plus 2/3.
1, and 1 plus 5 is 6.
So 5 plus 1 is 6. So what they did is they took that 3 and 1/3 and they broke out each part, and then they broke out that 2 and 2/3 and they separated out each part. And then through the power of math here, they said, wait a second, let's add these two numbers together to come up with 3/3. And they didn't type it this way because it's black and white, and it would have been confusing to draw like overlapping black and white lines. And they said, well, let's combine our whole numbers, 5. And so we really ended up with like 5 plus 3/3. And that's what we see up here, is that 5 plus 3/3. And we know that 3/3 is really the same thing as 1 whole. So it's really just 5 plus 1 to equal 6. So 5 plus 1 is 6. We're going to do the same thing on this next question. I'm going to add the whole numbers. I'm also going to add just the fraction. So what is 1/4, Kyson? 1/4 plus 2/4?
1/4 plus 2/4 is
Yeah.
3/4.
3/4. And Kyson, 4 plus 3 is what?
7.
So what do you think 4 and 1/4 plus 3 and 2/4 is?
4 and 1/4 is 7 3/4.
It's going to equal 7 3/4.
The next one would be 9.
How did you come up with 9, Nandini? I don't think you're wrong. Just walk me through it.
So what I did was, I just did it all in my head, and 2 plus 6 is 8, and then 2 6 plus 4 6 equals 1 whole, so 8 plus 1 equals 9.
So it really is like 8 plus 6 sixths. And you said, well, 6 6 is really the same thing as 1 whole. So you were thinking, well, 8 plus 1 whole, or 8 and 1 whole more, is equal to 9. Does that make sense to you, Kinley? How we added this 2 sixths and 4 sixths, and 2 plus 4 is 6, right? So adding fractions when the bottom number is the same, we just get to keep saying that bottom number name, right? Like I could say it's 2 cars plus 4, I don't know, cars, right? Cars isn't a unit of measure, but I'd have, if I had 2 cars plus 4 cars, I'd have 6 cars, right? What we can't do with fractions, I can't say like 2 cars plus 4 peanuts equals, well, I don't know, because a car and a peanut aren't the same thing, right? They're two totally different things.
2/3 plus 4 7.
Right. This is the same thing as like 2/3 plus 4, sure, 7ths, right? I can't add straight across and still keep this the same name. I'd have to figure out, well, how many peanuts are equal to cars, and quite frankly, I don't know that answer. I don't know what the conversion peanut to car is. But we can't add if those two are two different things. when they're the same things, all you're doing is just adding across the top. So 2/6 plus 4/6 is 6/6, right? It's the same thing as if I have something that is divided into 6 parts, right? And I'm shading in. Well, let's try that again. So if it's divided into 6 parts here, if I shaded in 3 of those, one color, and I shaded in 3 more, another color, how much of that circle is shaded, Kinley?
Well, I guess 3/6.
Well, so 3/6 is shaded in blue. How much of the circle is shaded in orange?
3/6.
Okay, so how many total sixths are either blue or orange?
6/6.
6/6, right? Could I simplify that and say one whole circle is shaded?
Ish.
Yeah, because the whole circle is shaded, right? So I've got one whole circle shaded.
Like 3/3.
Right, and that's why we said here that this 6/6 was the same as one whole. Because it's saying, like, hey, I've divided this into 6 parts, and of those 6 parts I divided it into, 6 of those parts are shaded. So all of it is shaded. The bottom number is how many parts you've divided it into. The top number is how many parts you actually have. Does that make sense? So if I've divided something into 6 parts and I have 6 parts, I've got all of it. If I've divided it into 6 parts and I only have 5, then I would say that I only have 5/6 parts. Because I've got 5 out of a total of 6 to make one whole. Let's take a look at this next problem here. We're first going to solve it, and then we're going to look at it on a number line. So here I've got 2 4/5 plus 1 2/3. Well, we're going to add our 2 plus 1 first. So I'm going to do whole number plus whole number. We're going to do fraction plus fraction, right? Add your whole numbers, add your fractions. Kinley, do you know what 2/5 plus 4/5 is equal to?
Well, I think that would be 1/6.
You were right where you were saying it's going to be 6/5, right? Because that bottom number is just the name of the fraction, right? That just helps me name it. It's telling me how many parts are in it. I don't do anything with that bottom number. So all I'm adding is 4 plus 2. 4 plus 2 is 6. And what name am I giving that fraction? Well, in this case, I'm giving that fraction the name fifths. So I have 6 out of 5 parts. So this is a shape that is divided into 5 parts. Let's see, that's divided into 4. Let me add a 5th part. We're going to pretend like all of those are the same size. So I have 1, 2, 3, 4, 5. If I were to have 6/5, it's going to look something like this, Kinley. I'm going to have all of 1, right? That's 5 of 5 parts. And then I've got 1 more of 5 parts. So here I'm showing that 6/5 is equal to, let's erase that, 1 whole and 1 out of 5 parts. And we see that here, right, Kinley? I've got 1 whole circle. That's okay. and I've got 1/5 of that next circle, right?
Yes.
Okay. So as long as you understand that like that's kind of what's happening when I add 4/5 plus 2/5. I got 6/5, but 6/5 is like yesterday's homework where we had fractions that were greater than 1. I'm going to pull out 1 whole out of that, and I've got 1 extra fifth. Now let's look at what 2 plus 1, that red part of our equation over here. 2 plus 1. What is 2 plus 1, Kinley?
It is 3.
It is 3. Now we're going to add all 3 parts together. What is 3 plus 1?
4.
And do I have a fraction left over still?
Yes. 1/5.
So 2 4/5 plus 1 2/5 is equal to 4 1/5. When I model this on the number line, I'm going to model each of these steps. So I'm going to start at 2. Plus 1. Right? That got me to 3.
Yeah, you got your 1. I have a question.
Yes.
Do we have to do this all the number lines like you're doing?
Nope. I could also have just started out at that 3 because that's the obvious, right? That 3 here. And then I could show here is my 5/5 plus my 1/5. And if you look, I am at 4 and let's look.
1/5.
1/5, 2/5, 3/5,
3/5,
4/5, and this would be the next 5/5, right? Like this would be the whole of the 4, like 1 whole greater than 4, and that would be 5. So I end up at 4 and 5/5. Let's take a look at this one. If I were to add 1/3, or 1 3/4, sorry, 1 3/4 plus 3 3/4, 1 plus 3 is 4. 3/4 plus 3/4 is 6/4.
You have a whole, so 5 2/4 or 5 1/2.
So I broke that up into a group of 4/4 and 2/4. Does everybody understand how I ended up first with 4 and 6/4? Is there anybody confused on that? Okay, so when I draw my number line, I'm going to start here at this 4 number. So I'm just going to start 4, 5, and we'll put even 6 on here because it makes me happy. Now, how many parts did we divide our fraction into? 4. Our fraction is in fourths. So when I'm subdividing my fraction line here, 1. Right, so this is 1/4, 2/4, 3/4, 4/4. 1/4, 2/4, 3/4, 4/4. 1/4. We'll have that be the halfway. All right. Let's model this. I started out with 4. And to that, I added 4/4.
So 1, so you can land on 5.
So here's my 4/4 plus 2 more 4ths. And I end up at 5 2/4. Now Nandini is going to tell me But Mr. Barry, 5 2/4 is also the same as 1/2. And that's true. 5 2/4 is also 5 1/2. You do not have to simplify it. If you want to leave it as 5 2/4, it's okay. If you get it and you're like, I need to simplify it to make myself a better human, you can simplify it. Okay, it's not really going to make you a better human. It is how we would express it, but it is okay to leave it as 5 2/4. It's okay to leave it as 5 1/2. If you get it, 5 1/2 is fine. If you're not really sure how to simplify yet, don't worry. That's not the point of this lesson. The point of this lesson is that you are just adding mixed numbers. You're taking two mixed numbers, you're adding the whole part, you're adding the fraction, and you're showing what's left. So let's scroll on down and let's take a look at another problem, something a little trickier for us. Okay, I'm going to use the arrow way to show how to make one. So all we're doing is I'm trying to make one.
3 9 6 or 4 3 6 or 4 1 half. Oh,
yeah, so here they combined the 2 plus the 3, or the 2 plus 1 to make that 3. They left this 4/6 alone. So we had like 3 4/6 plus 5/6. So how am I going to make 6/6? What more do I need to add to this 3/6 over here to make?
6. Is it 4 1/2?
Yeah, so I could take this 4/6 here.
Yeah. You get 6 6 or 1.
So I've got 3 plus 1 plus 3/6. And that's all we're doing here. You're just regrouping and reorganizing those fractions. Let's take a look at the next one. Here I've got 1 3/4 plus 3 3/4. I'm going to add my whole number together, and I'm going to leave this fraction here alone for now. So 1 plus 3 is 4. Yes? Not right now, Kennedy. So I've got 1 plus 3 is 4. And I was leaving this part of the fraction alone. So I've got 4 3/4 plus. Now I'm going to look at this 3/4 I haven't touched yet. Plus 3/4. Now, how many fourths do I need to add to this 3/4 to make another whole?
1/4.
Yeah, so if I pulled 1/4 out of this 3/4, I would have 2/4 left over.
Yeah.
These two right here combine to make another whole. So I've got 4 plus 1. That makes 5.
It's 6.
Plus 2/4. So I've got 5 plus 2/4 is equal to 5 2/4.
Now how about 3/4 and 2/4?
Right, because I added this 3/4 and this 3/4 to get really like 1 2/4, right? Or 1 1/2. Just like if you had 3/4 and somebody else had 3/4 and you combined those quarters, right? That's like 75 cents plus 75 cents, right? How much money would you have if you had 75 cents and then 75 cents more?
$5.02.
How about $1.50?
I just put. Oh yeah, $1. I didn't know. Or 150 cents. 150 cents or $1.50.
Could I say I have $1.50?
No idea. Yeah.
Yeah.
$1.50.
Same thing is happening here. 3/4 plus 3/4 is 1 2/4, or 1 1/2.
Or 1 1/2.
Let's look at this, combining them one more time on our problem set. And then problem 4 is you can solve using whichever method you prefer. So here I've got.
Can you put that through it in your head?
No, I need to see your work because I need to see what you're doing in your head. So I've got 3 3/8 plus 2 6/8. I'm going to combine just this part first. I'm adding my 3 3/8 plus 2.
3/8.
So 3 3/8 plus 2 is 5 3/8 plus our 6/8.
6.68.
All right. How many eighths do I need to add to this 3/8 to make another whole?
2 8. 5. 2 8.
I need to add 5/8 to this one to make another whole. Nandini was going to add to this one. We're going to try to make this one a whole first. So I need to add 5/8 to this one to make this one whole. And there'd be 1/8 left over. So if I add these two together, I've got another whole. So I've got 5 plus 1, that made 6, plus this 1/8, that equals 6 1/8. On question 4, you can solve using any method you like. Now, I kind of like adding my whole numbers and leaving this first fraction alone. To me, that makes a lot of sense in just the way we're organizing the problem. If that does not work for you, that's okay. But I think in my head, solving 1 3/5 plus 3 is really easy. Because, I'm just adding the whole number to this part of the equation. So I got 4 3/5. Then I have to think, well, what would it be if I added 4 more fifths to that? And I go, well, this one only needs 2 more fifths to make a whole nother whole number. So if I break that 4/5 into 2/5, and there'd be 2/5 left, these two together, 3/5 and 2/5, makes one whole. So I've got 4 plus my new 1 plus my remaining 2/5, 5 2/5. Does everybody see how we solved that problem?
Yep.
All right.